Okay, so here are the three different types of symmetry. These are what we're working on right here. We have the x-axis of symmetry. We have the y-axis of symmetry. And we have the origin of symmetry. Okay, so if it has symmetry about one of these, there's tests for us to figure that out. I'm going to separate the x-axis one because that one's pretty unique. The y-axis and the origin, those will get tested the same way. Because most of the time, these are called functions. All right. See, if I have symmetry about the y-axis, and if I plug in x and I get y, if I plug in the opposite of x, I still get y. That is symmetry about the y-axis. If it's the origin, if I plug in x and then I get y, and then if I plug in negative x and I get negative y, then that's symmetry about the origin. Now, can you look at it the other way? Yeah, you could look at it a different way. You could say negative x, then you get y, and then positive x gives you negative y, just as long as the signs both change. So let's look at number 15 first, because 15 is probably the easiest origin symmetry to think about. So the function for 15 is x to the third. If I took, just give me a concrete number, like a 3. If I plug 3 into that, what do I get for my y value? What's that?
27.
Yeah, 27. So for f of x, I get 27. And then if I plug in negative 3, what do I get?
27.
Negative 27, right? So see how the signs both change? Okay, this has symmetry about the origin. And that test that I just did with this proves it. That's algebraically. You could write it out too, but I don't really care, just as long as you have some numbers to show that you plugged it in. This is how you would show that you plug it in. You just do that thing, and then you get 27. Whatever. So that is symmetry about the origin, number 15. Because when we plugged in opposite x values, we got opposite y values, that means we're symmetrical about the origin. What about the y-axis? Well, since we did the x to the third, let's do an x squared. If I had x squared, what would that be symmetrical about? Yeah, this would be the y-axis one. See, if I plug in a 3 and a negative 3, I should get the same y values if we're symmetrical about the y-axis. I just picked two x values and I made them opposites. Opposites just means that the signs changed. What is 3 to the second power? 9. What is negative 3 to the second power? 9. You see how the y values stay the same? When the y values stay the same, that means you're symmetrical about the y-axis. So the algebraic test to check for symmetry for functions, these are only for functions right here, is simply to plug in a positive x and a negative x to see what you get. Now the x-axis, this one's a little different. The x-axis, these are not functions. If you're symmetrical about the x-axis, you're not a function. See, check this out. Here's it looks like a sideways absolute value function. This is symmetrical about the x-axis because this point is reflecting to this point. Okay, and they have the same x value. They have different y values. They have a positive y value and a negative y value. But if y was a 3, then the other one would be a negative 3. So they're still opposites. So for the x-axis, if you plug in an x, you get a y, and you get a negative y. So this is the only one that has the x is the same. So how do you know, like, when that happens? Well, it might happen right here because the y has a squared. It might happen right here because the y has a squared. Not here because you see how y is alone? Y is written in terms of x. That means y is all by himself. That's what it means. This one, I don't think so. Because can you get the y alone for number 20? Yeah, I can get the y alone for number 20, and if I can get the y alone for number 20, that means we have a function, and so it's going to be one of these. Let's look at number 19 really fast. It says x y squared plus 10 equals 0. All right, let's just solve for y. Let's see what happens when we try to make this into a function. If I move the 10 over, that would be a negative 10. And then if I'm solving for y, that means I'm going to get rid of that x also. So I would divide by x. X divided by x is 1, so I'm left with a 1 y squared. And on the other side, if I divide by x, I get negative 10 over x. Now, how do I get that y alone now? It has a little squared right there. How do I get him alone? Yeah, you're going to have to square root it. And guess what happens? What happens when you square root inside of an equation?
You have to square root the other side.
Yes, I got to square root both sides, but there's a rule that you have to do. So if I square root this side and then I square root this side, it's actually, never mind. So it would be y equals square root of negative 10 over x. Right now the negative is okay because I don't know what this x is. If this x is a negative, then the negative is going to go away and I'll be able to square root. But what do I have to have in front of a square root sign when I square root inside of an equation? Here, let me give you guys a quick example. If I have a number I don't know what it is. Actually, let's not use x, let's use m. And I square that number, and then I get 25. What can this number be? It can be negative 5, or it can be positive 5. Yes. So normally we would say plus or minus 5 to say it can be a positive or a negative 5. If I square root both sides here, this must have a plus or minus. So this right here must have a plus or minus. So look at that. If I plug in an x to this function, I'm going to get a plus y and a negative y. And you can actually plug in an x to test that, but just seeing the plus or minus is sufficient for me. That means that this is going to be symmetrical about the x-axis. That's the weirdest symmetry that you can get. Let's get a number for x and plug it in just to see what it looks like. Let's plug in. Now I'm going to be really strategic about the number I pick. Actually, let me show you what happens when I'm not strategic. If I just pick a 3 and I plug that into the x, let's see what happens. We have y equals plus or minus, and then we plug in a positive 3. Alright, so now we have 10 divided by 3. Now it's a negative 10 divided by 3. Can I square root a negative number? No, I can't do that. This doesn't work. Plugging in a regular 3 doesn't work. Alright, so let's be more strategic. Let's plug in, I want to plug in a negative 2 just because I know 10 can be divided by 2 and I want to get a nicer, pretty number. So I have y equals plus or minus, and I plug in a negative 2 to the bottom. Check it out. We get a negative 5. Negative negative is a positive, right? So now I have plus or minus negative 5. If I plug in negative 2, I get a positive 5, and I get a negative radical 5. So same x value, opposite y values. That means we're symmetrical about the x-axis.